we deposit a so-called principal. We're going to work on a problem in a minute. Let's say $50,000. That's our principal. We want to deposit it at the bank. And let's say they're giving us an interest rate of 2%, which means 0.02. That's the annual interest rate. Let's suppose we want to keep the money at the bank for 5 years. So that's that's T, letter T, the time in years. And let's suppose the bank recalculates the interest, let's say every month. And that's the number of times per year the interest is recalculated, compounded, in other words. So n is the number of times. So since there are 12 months, n will be 12. So in order to calculate something like this, what I just mentioned, since I put in some numbers, let's just work on it quickly. So the accumulated value in 5 years of $50,000, this will be 1 plus 0.02 because I mentioned 2%. And let's say divided by 12 because we want the bank will recalculate or compound the interest monthly. And then the power is 12 times the number of years that we want to keep the money. I'm going to share my screen so I can show you how to enter this in the graphing calculator. 1 second. Here it is. Good. So we have 50,000 and parentheses 1 plus 0.02 divided by 12. Close the parenthesis. Don't forget to put the caret. Some calculators don't require the parentheses around the power, but I don't know what calculator you have. So, and I'm in love with my parentheses, so to speak. I'm kidding, but I prefer parentheses than having to go back and check and change and so on and so forth. So I put parentheses. So the answer is the accumulated value will be, don't forget the measurement unit, 55,253.95. Because we're talking about dollars, we have to round to the second digit, which is the hundredth. So because the third digit is 6, 5 or more, in other words, then I have to round up the previous one. So it's 0.95, and that's dollars. So the accumulated value of an investment of a principal of 50,000 at 2% per year, annual interest rate, compounded 12 times a year for 5 years. Good. Other questions before we continue? Other questions for me before we move on to something else? Okay, then in that case, Georgie, do you want me to do anything? I thought you said something.
Yes. So for question 2
Okay.
on the written homework.
Can you remind us? I have not written solutions for it yet.
Sure. Graph the piecewise defined function.
Okay.
Table, domain, and range required.
Okay. Good. So will you remind us what was that? F of x equals, there were 2 branches.
The first f of x is negative 2 times x plus 6 for values less than or equal to 1. And then for the second one, it's negative x for x values greater than 1.
Good. So both of them had negative 2x plus 6 and then negative x?
Yes.
Okay, perfect. So again, we change this into negative infinite 1, and we change this into 1 to infinity. It's easier to identify the domain, and the domain is always required. So then I know that the domain is all real numbers because nothing is missing. There is no gap. Everything from negative infinity to 1, including 1, and then from 1 to infinity. So all real numbers. I have to have 0 and 1 in the table. 0 is always in the table. I shouldn't say always, because if the function is not defined at 0, of course I'm not going to put 0 in there. let's say the domain is only 2 to infinity. I'm not going to put 0. If this is 2 to infinity, there is no place for 0. Good. But under 1, I have these symbols, and they are touching. So this is a bracket to the left and a parenthesis to the right, which means if these two numbers are not the same, this will be a full point and this will be an empty point. On top, just to make sure I don't make a mistake, I will write negative 2x plus 6, and I will write negative x. I will plug in 0 and get 6. I will plug in 1 and I get positive 4. I will plug in 1, I'll get negative 1, and I will plug in 2 and I get negative 2. This problem should not take more than half a minute. It's just algebra. There is nothing about calculus in it. Okay, so 0, 6, 1, 2, 3, 4, 5, 6, and 1 comma 4. And they are both full points. And I'm going to use a different color just to make a point. You don't have to. And 1, negative 1 is right here, and 2, negative 2 is right here, and that is the graph of the function in question. Any questions, anybody, on this? Now, the table is there. The domain is very clear because it's right here. But what about the range? So again, the range goes from negative infinity to negative 1, up, it's a gap, and then from 4 to infinity. So the range of this function is negative infinity to negative 1 with an open, with a parenthesis. When we say parenthesis, we mean open. When we say open, we mean parenthesis. Union from 4 to infinity. Again, this has nothing to do with this course. I just wanted to review this because it's very important for chapter 1, in which we're going to determine limits, etc., etc., continuity, all sorts. Okay, anything else? Other questions for me? Anyone? Okay, so I'd like to come back to what we just did with another example, and feel free to choose. If there is anything that you have for me, always stop me, please. George, is this okay? Sorry, is this okay?
Yeah, I see where I messed up. I made a mistake with a negative sign. So instead of negative 2 times negative 1, I multiplied 2 times negative 1. But yeah, I was following.
Okay, very good. Okay, so let me open. Where is my book? I had it ready. Okay, here it is. I have it. Good. So I like to look at something like this only because I want to make a point, and if you want me to record the screen, then I will, and I'll wait for you to turn off your cameras. Or although I can take you out of, so to speak, but it may not work completely. I don't know. We'll see. So compound interest. So now we have 100,000. We are depositing. This is our principal. And the interest rate they give us is 2.8%. How much is the investment worth? In other words, what is the accumulated value? Of course, rounded to the nearest cent, as we know, at the end of 1 year. I'm going to change this 1 year into something else. Let's say 5 years. If interest is compounded, recalculated, in other words, annually, means once a year. Semi-annually means n is how much for semi-annually? N equals?
Twice.
Exactly. Quarterly, n equals?
Before.
Exactly. Daily, we consider 365 days per year, and hourly, 365 multiplied by 24. But what I would like us to do, so I'm going to just copy, so this is 31 on page 11. So I copy the formula first of all, 1 plus r over n raised to nt. the principal, so I'm just going to copy 100,000, and 1 plus the interest rate cannot be in percent, has to be as a decimal number, divided by x, and I'll explain the x in a minute, and I changed the problem into t equals 5 years. So you can see 1 year may be a little bit confusing when I put the 1 in there, that's why. So we know that annually we discussed n equals 1, then n equals 2, and then n equals 4, and then n equals 365, and finally n equals 365 times 24 hours. Okay, so n the power x times t, which is 5x. And you can say, what are you doing here? I personally, you can do whatever you want, of course, but I personally refuse to perform these calculations 5 times. What I am going to do, however, I am going to enter this function in the graphing calculator. The reason I wrote x is because we don't have n in the calculator. We have x. So then I will make x equals 1 and immediately get the answer. Then I will make n equals 2 and so on and so forth. So now I'm going to go back to the calculator. Let me know if you want me to record this, and if you do, if you say yes, then I will record after you turn off your cameras. Do we need to record this? I think I have recorded it already, and I think I transferred it, but let me know. So it's a yes, Haley?
Yeah.
Okay, perfect. So I'll wait for you then, for you to turn off your cameras for a second. Very good, thank you. Because I don't want to record anything that we don't need to. Nobody will see it, it's only in the course, but just to make sure. Okay, so where is my record button here? Record. Okay, perfect. So I will enter in y equals, I will enter the function as is. What do I mean? Well, 100,000, and then parentheses, and then 1 plus 0.028 divided by x. Here's x next to alpha. Close the parenthesis, caret, which is the power, and parentheses because I like parentheses. And once I enter the function, all I have to do, if you remember last time we did this together, second and table set, make sure that the independent variable, only the independent variable, is in the ask mode. If not, scroll down to the right, highlight ask. So now, since it's ready, I go and I am allowed to plug in the numbers I want. What numbers I want? I want 1, I want 2, I want 4, I want 365, and I want 365 times 12. I'm sorry, times 24 hours. Okay, now this is difficult to read, so I have to go back up and highlight them. Once I highlight them, you see the decimal digits. So the first one that I copy is A of 1, which is 114,806.26. Then A when n is 2, down. 114,915.75. Then A of 4, down. 114,971.29. Then A of 365, down. So 115,026.76. And finally, the last one, A of 8,760, which is 115,027.35. Okay? So I'm going to stop the recording. Okay. So, performing these by hand or entering them one by one, chances are, or I should say, the risk is high that you're not going to get the correct answer. Once you create the function and only plug in these numbers and not redo the calculation, maybe miss something, maybe change the division to a product, who knows? And notice that they have to be close to each other. I had many results from students. The first one was 200,000, the next one was 150,000, the next one was 2 million. No, it's not possible. They have to be quite close to each other. As you see, they're very close. 800, 900, 971, 1,000, 1,000, basically, right? So they have to be quite close. So this is the way I recommend. Do not do it by hand and enter and enter and enter. Create the function and plug it in. Any questions? There is also something that we will talk about in chapter 2, not in chapter 1, in chapter 2. Continuously compound or compounded interest. It's a different formula. I'm going to write it here because they should go together. So that is A equals PE to RT. We're going to talk about it in detail in chapter 2. What is this? The same thing. The same accumulated value, the same principal, the same annual interest rate, the same number of years T. All these have the same meaning. The only difference is that this is something called Euler's number. It's a constant. And where do I find it? Here's where I find it. Right here in blue. And another place right here with a division symbol. So let me quit there and second an E. It's an irrational number. It goes on forever with no pattern. It cannot be changed into a fraction. And it's Euler's number. It bears the mathematician's number because he, so to speak, if you want, he developed it. He showed how important this number is in nature. And we're going to talk about it in chapter 2. So I want you to have both formulas and understand that this formula is for interest compounded n times per year. And this is the formula for interest compounded continuously, every second, continuously. And that's a different formula. We're not going to talk about it more right now. We're not going to use it right now. But it's coming up in chapter 2. So there are two different formulas. Compound interest n times a year and continuously compounded interest. Okay. Moving on. The other thing that I wanted to show here is the annuity formula, something that looks awful. And I did record this. I'm pretty sure I posted it. I dragged it from a different section. Where is my class? I lost my class. I found my class. Okay, so I think I did post it, so we don't have to record this. Is it opening or not? Compound interest with TI-84. So it's recorded, it's right there. Good. So what is this formula all about? This formula, the annuity formula, is used, for example, let's say we want to borrow, not deposit money. We want to borrow. We want to buy a house. We want to buy a car. This is the way they calculate our monthly payments. So if we borrow, let's say we want to buy a car and we borrow, let's say $30,000, the interest rate, let's say 3%, it doesn't matter, or we can work on a problem in a minute. And N is the total number of months. So 60 months will be 5 years. Okay? So anyone would like us to calculate? Can you give us how much we want to borrow? So it's an ugly formula. Difficult to enter. That's why I recorded it and I already posted it for you. A little bit difficult to enter in the graphing calculator. So how much money do we want to borrow? And let's say at 3% interest rate, which is 0.03. Now let's say N equals 60 months or 5 years. So how much do we want to borrow? What car do we want to buy? Or what house, how much do we want to borrow? Anybody?
$240,000 for a car.
We want 40,000?
Sure.
Is that what you said?
Yeah, 40.
Okay,
I feel like
perfect.
that's a pretty good car these days.
Okay, perfect. Good. So let's enter this. Actually, before we enter it, let me explain what I'm going to do. So this has to be in parentheses. Then the top is okay. So P, the 40,000 times 0.03 divided by 12, which has to be in parentheses. Then parentheses, the same thing, 1 plus R over 0.03 divided by 12. And then the power will be 60 months. But now in the denominator, I need another set of parentheses. Because otherwise, the calculator will not perform the calculations we expect. And we're going to calculate how much we should pay per month for 5 years or 60 months to pay back the loan. So here it is.